Okay, welcome. Today we're going to be talking about 6.05, the antiderivative. This was our do now. It was something along these lines. I just made this up. But we have f of x, and you got to find the derivative, f prime of x, the derivative function. And we just have to remember some derivative rules, like if we take the derivative of cosine, it's negative sine. Right? And then for these, when we take the derivative, go from f of x to f prime of x, we have to do the power rule. Now let's see, what is that? How does that work? Well, we make sure that we have an exponent there. Remember, we subtract, or first we bring down that exponent. So we're gonna do like 1 times 2x. And then we subtract that, right? 1 minus 1. And we would get here is like 1 times 2 to the x to the 0, which we know really is just 2, right? Remembering this, right? You just remember that if we take the derivative of 2x, we're gonna get 2. Same thing with this one here. We bring this 5 down and we get 5 times that 3x. We multiply those first two. And then we would subtract 1 from that exponent. And that would become a 4. So we get 15x to the 4th. So we got to remember basically our rules for the derivative using our power rule were what? To basically bring down the exponent to the front and multiply it, right, by whatever that coefficient was, right? I brought that 1 down and multiplied it, brought the 5 down and multiplied it, right, in order to get the 15. And then step 2 would be to subtract a power from that exponent. So a 2-step process there. And why I'm saying this, you're like, Kirsch, I got it. I know this stuff. What about these next two? These next two, what we're going is, we're going backwards. We're talking about basically, what did I have to start in order to have a derivative of 8x and x to the third? And this is kind of something that we've talked about a little bit, is called the antiderivative. Okay, so how would I do that? Now I could guess and check, and I could say, well, okay, what was, brought down, and I could try some things here. I could take a step back and think. Anytime I take the derivative, my power goes down 1, right? There was an x to the first here, and then there was an x to the 0 here. There's an x to the 5th here. There's an x to the 4th here. So when I take the derivative, my power goes down. So I must be thinking about, what power did I have here? It must be a little bit bigger. So the first thing that I'm going to do to take my antiderivative, I'm just going to add 1 to the power. So let's see, that's going to become x to the 4th. Right now I can see, all right, if I would take my derivative, I would be going backwards. Now, there might have been something, being multiplied on the front there. So what I'm going to do is I'm going to do the exact opposite. We're going to divide. And I would divide by whatever that was, an x to the 4th. Now, if you think about this, now I could actually try this. Bring the 4th down, those 4s would cancel, and I'd have that 3 there. Let's try this with the 8x. First, let's add a power of 1. It's going to become x to the, it was x to the 1st, right? So if I add a power there, that becomes x squared. And we'll keep the 8 on there, and then we'll divide by, sorry, I just got some stuff in the way, whatever that power was. So in this case, I'm going to divide by 2, which gives me 4x squared. Let's see if that works. If I bring that 2 down, do I get 8? Yep. If I subtract 1, do I get 1? Yep. So this would be kind of what I needed to start in order to get that 8x. So what did I do? I went backwards. So instead of doing the derivative of multiplying and then subtracting, I actually added and then divided. So the exact opposite in the exact opposite order. That's kind of how inverses work. So we've got these two kind of concepts. The derivative, right, goes one way. The antiderivative can have us go back. Right, now there's some annotations and some notations for the antiderivative that we'll get into, but let's actually go into defining it and talking about some more examples. So let me clear this. Our notes are going to be titled 6.05, anti-power rule for indefinite integrals. Indefinite integrals, meaning the integrals aren't defined from here to here, right? Start to finish. It's just kind of like, this is the integral. How would you do the antiderivative? Let's get into an example. We have an integral x to the third dx. So what we have here is this actually means anti-derivative. This is the integration symbol, right? Sum for summation when we were talking about areas and stuff like that. So let's just remember our rules here. To do the antiderivative, we want to work backwards. Think of this as being f prime. We want to get back to f. So what we're going to do here is we're going to add 1 to the power, and we're going to divide by the new power. We could always check it by going backwards and looking at our answer and taking the derivative to make sure, because there's this kind of relationship there back and forth. So when I do something like this, let's see, if I add 1 there, that's going to give me x to the fourth divided 1, right? I added 1. Now I'm going to divide by the new power. My new power is 4, so I'm going to divide it by 4. Now, when we have this, this is good. We're going to add a plus c. And the reason why we have a plus c is because if you think about taking the derivative here, you do not need to write this down of x to the fourth plus 10, or x to the fourth over 4, sorry, minus 3. If I take the derivative of each one of these, right, let's call these f, and I find f prime in each case, what I would do is I'd bring that 4 down front, and I'd have 4 times x to the third over 4, right? Those 4s would cancel. So that would give me my x to the third, right? This is me checking. But if I took the derivative of 10, I'd get plus 0. Same thing down here. If I took the derivative of this one, I get x to the third plus 0. So I get the same thing in each case, because remember, when we take the derivative of a constant, it's always going to be 0. So basically what we're saying is here, we don't know if there is a constant there or not. We, in fact, have no idea if this problem started with an x to the third plus or minus something, sorry, x to the fourth plus or minus something, in order to get that x to the third plus 0. We don't know if there is a constant there or not. So what we're going to do is we're just going to mark it as having a plus c. That's it. Let's do another one. An indefinite integral, let's say 8x dx. So what we're going to do is we're going to add 1 to the power. There's a 1 there, right? So that becomes 8x squared. And then we're going to divide by whatever that new power is. And we could always simplify that. We'll write there as plus c dx. And we could always simplify that. Let's see, 8 divided by 2 is 4. Now I could always check this by doing the derivative, move the 2 down. That would give me an 8, right? And then I would subtract 1 to get a 1 right there. So here's my answer. If I integrate, take the integral of 8x dx, I will get 4x squared plus c dx. The dx is telling us with respect to x. We're going to do a couple more. So let's clear this. These should all be going in your notebooks. The next one being, let's see, we've done those two. Let's take a look at the indefinite integral of some constant, 6, dx. When we do this one, what's kind of interesting about this is the same thing. You might say, oh, there's no x there. You're right. It's really like a 6x to the 0. So I might want to rewrite this if there isn't an x. We might want to put it as x to the 0 power, not because that's 0, but because remember x to the 0 power is actually 1 whole, right? So that'd be like 6 times 1 whole, which is that 6 there. So basically, if there is no variable, we can actually put one in with an exponent of 0, so to speak. Now that I have this, let's do our anti-power rule. we're going to add 1 to that exponent. Well, adding 1 to that gives me an exponent of 1. So I keep the 6 on there. And then I'm going to divide by whatever that new exponent is, which is 1. So I get 6x to the first over 1, which is equal to 6x. And I'm going to just remember to put the plus c dx in there. So if I take the derivative of 6x, we just get regular 6. We take the derivative of a constant, we get 0. That's why that's not there. This is my final answer. Last one. Let's say 8x to the third dx. And in something like this, and once again, let's see. I'm doing the antiderivative, so I'm going to add to my exponent. 3 becomes a 4, and then I'm going to divide by that new exponent. Did I already do this one? I think I did. Forgive me. Should have looked at the last page of my notes. I won't bore you with more. This is it, right? If we can remember those 2 steps and we can identify this integration symbol as being the antiderivative, right? And the anti-power rule, then we're going to be all set. And just remember, we're going to add 1 to our exponent, and then we're going to divide by that same thing. That's the anti-power rule. Good luck to you. Remember the plus c, because if you take the derivative of c, we'll always get 0. Remember that dx on the end of that once we've taken the antiderivative of these indefinite integrals. Good luck. Take those notes, submit those to Google Classroom. See you.